First, we're going to look at an example that uses Hess's law. In this example, we want to calculate the delta H for this reaction using the following heats of reactions that are given. So first, note that we need carbon and hydrogen on our reactant side, and when I look down here, here's carbon and here's hydrogen, and they do already happen to be on the reactant side. And then on the product side, I need C2H2, and so if I look down here, there's C2H2, but it's not on the product side of the reaction like I need it to be. So the first thing that'll end up happening is we're going to reverse this reaction. And when we reverse this reaction, that means that we're going to change the sign from a negative to a positive. So now this reaction has 2 CO2 and H2O on the left-hand side, and on the product side we now have our C2H2 plus 5/2 oxygen. And notice that the sign was changed from negative to positive since we reversed the reaction. Okay, the other two reactions do not need to be reversed. However, if you'll notice here, there's a coefficient of 2 in front of carbon, and here we do not have a coefficient of 2. So what that indicates is I'm going to need to multiply all of this reaction by 2. And so when I distribute this 2 across the entire equation, we get this reaction here, 2 times the carbon, 2 times the oxygen, and 2 times the carbon dioxide on the product side. We also have to take our delta H and multiply it by 2 as well. The third reaction is going to be left the way it is because hydrogen is on the correct side and it has the correct coefficient. Remember, our final equation is supposed to be 2 carbons plus hydrogen yields C2H2 gas. So now let's look at these. These are our equations that we reversed as well as multiplied by 2. And now let's make sure everything cancels, yielding us just this. So we have 2 CO2s on the reactant side of equation 1 and 2 CO2s on the product side of equation 2. So that means they are going to cancel with each other. We have an H2O as a reactant liquid in equation number 1, and we have H2O as a product liquid in equation number 3. And so those will cancel out with each other. We have oxygen here, here, and here. Notice these two oxygens are on the reactant side, so if I combine them, and if I were to give this a denominator of 2, it would become 4/2. And 4 plus 1 makes a combination of 5/2 oxygen on my reactant side. And on my product side here, I have 5/2 oxygen. So these oxygens cancel with this oxygen. And notice what we have left is our 2 carbons, our hydrogen on the reactant side, and our C2H2 on the product side. So that's how we know that we've got the equations set up. Now I can take these values and I'm going to combine them or take the sum of them, and that's going to give me the delta H for this reaction. So we'll have positive 1,299.6, notice they're all in kilojoules, make sure our units are consistent, plus 2 times negative 393.5 plus negative 285.8. And that's going to give us an overall positive 226.8 kilojoules per mole for the entire reaction. And that would be the delta H of this reaction.